Hello friends, my name is Manoj Chaudhary and welcome to today's session on sequences and series. So if you remember in my previous video, we already discussed all the details of arithmetic progression and also all the details of geometric progression. So this session belongs to problem solving. So before that, let's revise the entire summary of geometric progression. So here I am discussing first the summary of geometric progression. So if you remember how to identify a sequence in geometric progression, so there is a one simple condition. Condition for GP is T of n plus 1 upon Tn is constant, right? That is, the meaning is the ratio of two successive term is constant. So do a simple thing, observe the given sequence and just take a ratio of two successive terms. So friends, not any random terms, but consider any two successive terms and find out the ratio, and if the ratio of successive terms throughout remains constant or same, then we say that given sequence is in geometric progression, right? And if you observe any geometric progression, it will look like A as a first term, AR as a second term, AR square as a third term, AR cube as a fourth term, and so on. And this one is a last nth term. And as a basic terminology, you know that first term of geometric progression is nothing but A, and this R is called common ratio. Then we also derived nth term of geometric progression, which is also called general term of geometric progression, because it represents each and every digit of that sequence which is present or the hidden, right? So this is the formula for Tn that you have to remember. So nth term of geometric progression is given by Tn equal to AR raised to n minus 1. Then we also discussed how to find sum of n terms of geometric progression. For that, we discussed three different cases. Case number 1, in which R was less than 1. Case number 2, when R is greater than 1. And case number 3, what if R is equal to 1. So friends, the case number 1 is if R is less than 1, then formula for Sn is A times 1 minus R raised to n upon 1 minus R. But if the ratio of two successive term is greater than 1, so greater than 1 means like let's say 1.5 or 2 or 3 something, then in that case formula for Sn is of slightly different than the previous one. It is A times R raised to n minus 1 divided by R minus 1. So right, and this case number 3 was something different that we discussed in previous video. What if ratio is 1? If you remember, if the ratio of successive term remains 1, then the entire sequence includes only one type of digit like 5, 5, 5 and 5. So right, then and then only the ratio is equal to 1. In that case, if you want sum of n terms, please use this formula. Sn is equal to n times A. So friend, this is, once again I am repeating, this is the revision of the previous lecture, or this is the summary of the geometric progression. Before this video, you must watch the previous video on all the concepts of the geometric progression. So right, okay, then for the problem solving purpose, this is important one. So here I am marking this as a note number 1, how to find numbers in geometric progression. So right, we discussed this particular question in previous lecture, how to find numbers in geometric progression provided product of numbers is given. So there are two cases, either they will provide you the product, so please observe this thing, either they will provide you the product of all the numbers, or might be they will not provide the product of the number. So please observe, these are the two cases possible. Either they will provide you the product, this is the case where I am assuming the product is given, and this is the case where I am assuming product is not given. These are the two different cases. So read the exam problem very carefully and observe that a product of the all numbers is given or not. If it is given, then this is the note number 3. And if it is a question of 3 numbers in GP, how to find 3 numbers in GP, for that please select the numbers in this way. This is the first number, A upon R. This is the second number, and this AR is the third number. So select the first number as A divided by R, second number as A, third number as AR, and simply follow the statement of the problem. You will get all the three numbers in GP. Then how to find four numbers in GP if product of four numbers is given? Then please select all the four numbers in this way. First number A upon R cube, second A upon R, third A into R, and fourth one AR cube. So right, if you remember, we discussed this thing in previous lecture. First number A upon R cube, second A upon R, third A into R, and fourth one is AR cube. Then 5 numbers in GP. How to solve a question on 5 numbers in GP? If product of terms is given, then please select the 5 numbers in this way. This is first, this is second, third one is A, fourth one is AR, and fifth one is AR square. So once again I am repeating, the first number is A upon R square, second number is A divided by R, third number is A, fourth number is AR, and fifth number is AR. So friends, once again I am mentioning here, please apply these hints or tricks only when product of numbers is given in examples, right? So this is a question of 3 numbers in GP, 4 numbers in GP, and 5 numbers in GP. So this is the hint that you have to use while solving a problem. What if the product of numbers is not given? So right, so many times you will observe a question in which product is not given. Then how to select 3 numbers in GP? So this is the first number, this is the second, and this is the third. If it is a question of 3 numbers in GP whose product is not given, then this is the way that you have to select 3 numbers in GP. The first number is A, second number is AR, and third number is AR square. What if it is a question of 4 numbers in GP? Just extend this thing. So this is the first number A, second number AR, third number AR square. Just add one more. Fourth number is AR cube. This is the ordinary way that you have to select the numbers if product is not given. You know that this is the way that we represent a geometric progression. So right, if it is a question of 5 numbers in GP, then the first number is A, second number is AR, third number is AR square, fourth number is AR cube, and the fifth number is AR raised to 4. So this is the way that you have to select 5 numbers in GP if product is not given. So that's all friends. This is all about entire summary of this geometric progression. I hope you got this entire summary of the geometric progression in this. So try to recall each and every details of this. So let's try to face few questions on summary of this geometric progression. So here I am starting with example 1. So they want us to check the given sequence for a GP, and if it is in GP, then also find Tn. So friends, how to check a sequence in GP? So for that, just take a ratio of successive terms like 6 divided by 2, and you know that it is 3. 18 divided by 6, it is also 3. 54 divided by 18, and this is also 3. And if you observe, the ratio of successive term remains same, means the sequence is in GP. So here I am mentioning the given sequence is in GP. The reason is the ratio of successive term is constant, and you know that ratio we denote it by R. So here, as far as this GP is concerned, the ratio is 3, and you know that this 2 acts as a first term of geometric progression. So in this case it is 2. Then please apply formula for Tn. So try to recall formula for Tn. So please recall formula for Tn. Formula for Tn is AR raised to n minus 1. So I hope you are able to recall this formula. So this is the formula for Tn. Tn is equal to AR raised to n minus 1. Now if it is in GP, they also want the Tn. So substitute. Value of A is 2, value of R is 3 raised to n minus 1. That's all friends. This is the nth term of that geometric progression. If you want, you can keep this thing as it is, or if you want, you can simplify this thing further. So I'm keeping this 2 as it is. As a laws of indices, you can split it as 3 raised to n, 3 raised to minus 1. Then this is twice of, if you shift this 3 raised to minus 1 in the denominator, it becomes 3 raised to 1, 3 raised to n. This is nothing but nth term of geometric progression. So this is example number 1, in which we checked whether the given sequence is in geometric progression or not, and it is in geometric progression. and we also find it out nth term of geometric progression. Okay, let's quickly discuss the same question. You have to check whether this sequence is in GP or not, and if it is, then you have to find Tn for it. Okay, so if you observe, the first term is 1. Let's try to take a ratio of successive terms. So that is minus 5 divided by 1. This ratio is minus 5. Then I am taking the ratio of this successive term, 25 divided by minus 5. Answer is minus 5. Then one more to cross check. It's a minus 125 divided by 25. Answer is minus 5. And if you observe here, the ratio of successive terms remains same. The ratio of successive terms remains same. Therefore, the given sequence is in geometric progression. So, right? Okay, let's quickly find out the value of Tn. So, formula for Tn is ar raised to n minus 1. So, right? Just try to recall. Formula to find nth term of geometric progression is Tn is equal to ar raised to n minus 1. Please substitute the value of a. So, value of a means first term. So, first term of sequence is 1. Ratio in this case is minus 5 raised to n minus 1. So friends, if you want, you can keep this thing as it is. So final answer is minus 5 raised to n minus 1. This is the nth term of the given geometric progression. So right, okay, let's switch to the next question. What about this example number 3? So the question is whether this thing is in GP or not. So to check whether the sequence is in GP or not, just try to take a ratio of successive terms. 14 divided by 7 is 2. What if you divide this 21 by 14? So division goes through by 7. So 7 3s are 21 and 7 2s are 14. And here itself, condition for GP fails because the ratio of first two successive term is 2, but the ratio of next two successive term is 3 by 2. Since this ratio is not same, right, means the given sequence is not in GP. So please observe, the given sequence is not in GP. So please mention this sequence is not in GP. So there is no need to find the nth term of this term. Oh, example. Okay, now let's switch to the next problem. Now they already mentioned that this thing is in geometric progression, and they provided you the ratio of that geometric progression equal to 1 by 3. First term is 9, and they want you to find 7th term of geometric progression. So for that, quickly use formula for nth term of geometric progression. Why I am using the nth term? Because nth term is also called general term of geometric progression, and you can apply that formula to any term of that sequence. So formula for Tn is ar raised to n minus 1. Since we want to find T7, that indicates n value in this case is 7, a value is 9, r value is so a value is 9 and r value is 1 by 3, raised to n value is, if you observe, 7 minus 1. So that's all. So let's simplify it further. This is 9 times 1 upon 3 raised to 6. So quickly find out answer for this one. So 9, this 9 we can express it as 3 square, and this is 3 raised to 6. So 3 square cancels. So it's a 1 upon 3 raised to 4. So please send me your answer for 1 upon 3 raised to 4. And you know that 3 raised to 4 is 81. So the 7th term of that sequence is 1 by 81. This is the benefit of using formula for nth term. So nth term can randomly give you any term belongs to that geometric progression. This is the interesting part about this nth term. Without knowing that entire sequence, without knowing each and every term of the sequence, directly you can calculate any term of that sequence. So this is the benefit of this. So let's try to tackle the next example. So example number 5, the given sequence is in geometric progression. They provided you the ratio of that geometric progression. So r equal to minus 3. Also they provided you the sixth term of that geometric progression, and they want value of a. So right, okay, so here I am starting with the formula for nth term of geometric progression, and formula is ar raised to n minus 1. So right, since they are talking about T6, so here I am applying this formula for nth term to this T6. So T6 indicates n value in this case is 6. And we have to find a value of A. I am keeping this A as it is. R value is minus 3. N value is 6 minus 1. So please do this calculation. So here I am substituting the value of T6, which is given equal to 1701. This is A and this is minus 3 raised to 5. So right. Okay, so since it's a odd digit to the minus sign, so this is a minus sign and 5 is an odd term. Minus raised to odd term is always a minus, and you can express it as 3 raised to 5. Then I'm shifting this 3 raised to 5 on this side. So what is the final answer for A? Also shift this minus sign on this side. So it's a minus of 1701 divided by 3 raised to 5 is the final answer for this question. Quickly find out this value of A for this problem. So if you observe, this A is minus 1701 and 3 raised to 5 is 243. If you simplify it, you will get value of A equal to minus 7. So these are the very simple questions. Ratio is given, sixth term is given. What you have to find out was A, and here we got A equal to minus 7. Okay, let's go to the next question. Example number 6. Once again, the given sequence is in geometric progression. A value is given equal to 2 by 3. Sixth term is given equal to 162. And what you have to find out here is a value of R. Okay, so let's start with this next problem. So here I am once again starting with formula for nth term. So Tn, formula for Tn is AR raised to n minus 1. And since they are talking about T6, let's utilize this formula to find T6. T6 indicates n value is 6. Keep this thing in mind. So A value is 2 by 3. R is unknown that you have to find out. So I am keeping R as it is. Substitute the value of n as a 6 minus 1. So T6 in this case is 2 by 3 R raised to 5. So do one thing, substitute the value of T6 which is given. If you observe, T6 is 162 and this is 2 by 3 into R raised to 5. Okay, then shift all this 3 and 2 on this side. So finally, what is R raised to 5? R raised to 5 is 162 into 3 divided by 2. I request every one of you to simplify this thing and find out the value of R. If you simplify it, 162 into 3 divided by 2, you will observe this is 81. So 81, we can express it as 3 raised to 4. This 3 is always 3 raised to 1. Togetherly, if the base is same, you can add these indices. 4 plus 1 is 5. So if you observe, if the index is same, then obviously these base terms R and 3 are also same. By comparing these two things, you will get value of R. So try to observe. Since the index 5 is same here, so here I am equating R equal to 3, and this is the final answer for this very interesting question in which A was given, sixth term of the geometry progression was given, and what was asked was equal to R, and here we got R equal to 3. Next, question number 7. So, which term of GP? So once again, the sequence is in GP, but they want the term in which, so see, this is the first term of GP, this is the second term, this is the third term, this is the fourth term, but they want a term in which 5 raised to 10 is present. So right, so this is the meaning of this question. They want the term in which, we don't know whether it is in present in 7th term or 10th term or 15th term or 16th term. So we don't know in which term 5 raised to 10 is present. So that's what they exactly want, a term in which this 5 raised to 10 is present. So right, then let's crack this question of geometric progression in which first term, that is A, is 5, and what is the ratio? To find a ratio, just take a ratio of two successive terms. So 25 by 5 is 5. So in this case, A is 5, R is 5, and here I am writing a formula for Tn as AR raised to n minus 1. Since we don't know the term in which 5 raised to 10 is present, I am keeping Tn as it is. A value is 5, R is 5 raised to n minus 1. So right, if you observe here, the index of 5 here in this first term is 1, means Here I am free to do this simple calculation. So since it is a 5, this one is also 5. So base is same. If the base is same, then you can add its indices. So it's a 5 raised to 1 plus n minus 1. So here I am doing a laws of indices like a raised to x, a raised to y is a raised to x plus y. Since the base was same, so I added the powers. So this plus 1 and minus 1 cancels. So since we don't know the term in which 5 raised to 10 is present, so try to observe. We want to find a term in which this 5 raised to 10 is present. So here this question you can solve very easily by observation. They want the term in which 5 raised to 10 is present. That clearly indicates this n in this case is 10, right? So here this gives you an idea. N value in this case is 10. That indicates it is a 10th term in which 5 raised to 10 is present. So this is the meaning of this question. So they want the term in which 5 raised to 10 is present, and here we got by observation and by doing some calculations on nth term of geometric progression, it is a 10th term in which this 5 raised to 10 is present. So right, this is by observation or by comparing these two things that leads to the n equal to 10. Okay, so let's discuss the next one. Example number 8. For what value of x? Very interesting problem. For what value of x these terms 4 by 3, then x, and then 4 by 2, 7 are in GP. Very interesting question, friends. So according to them, these are the three terms, and these three terms are in GP. So here I am going to use condition for GP. So what is a condition for GP? Condition for GP is ratio of two successive terms is always constant. So ratio of two successive terms is always same or constant. So right, instead of constant I am using a word same. It will be very simple to understand this. Okay, so since this is in GP, so here I am taking the ratio of these two terms, means x divided by 4 divided by 3. This must be equal to the next ratio, that is I am dividing this 4 by 27 with this x. So friends, try to understand this thing. So the ratio of 2 with 1 is r, the ratio of 3 with 2 is also r, right? So this ratio is also r, this ratio is also r. This is what the condition of geometric progression. If a given sequence is in geometric progression, then the ratio of two successive terms remains same. So therefore, the ratio of first two terms and the ratio of third and second term remains same. And this is the thing that we want to calculate here in this question, right? So now let's do the calculation. So here I'm shifting this x on LHS, that leads to x square. I'm shifting 4 by 3 on this side. So it's a 4 by 3 into 4 by 27. So is it correct? Okay, so this is x square. This 4 into 4 is 4 square, and 3 into 27 is like a 3 raised to, this 27 is actually 3 cube. Is it like a 3 raised to 4? Right? Or you can express it as 81 if you want. So it's not like that. You do the calculations in exactly the way I do. Please calculate and do your own way. So this is 4 by 3. So this is 4 square. This is 3 into 27 is like 81. 81 is a 9 square. If you want to remove this x, what is the possible value of x here? So possible value of x is 4 by 9. So right, so final answer for this question is 4 by 9. More specifically, if you remove the square, make sure that you put a plus and minus sign. The reason is quite simple. If I am talking about x square equal to, let's say, 9, and if you want to remove the square, make sure that you write it as plus minus 3. The reason is quite sure. Square of plus 3 is 9 and square of minus 3 is also 9. So there are the two possibilities. Therefore, we always mention plus and minus while removing the square. So here also, since you want to remove the square, if you are removing the square, make sure that you mention plus and minus sign as a value of x. So here this one was a very small and very interesting problem. What was given was, for what value of x the given three terms are in GP. This was a very simple problem. Just use a condition for GP, and you know that for GP the ratio of two successive terms remains same. The ratio of x with 4 by 3 and the ratio of 4 by 27 with x remains same, and on the basis of that do some calculations and you will get value of x. Okay, so here I am switching to the next level of the problem. Now this is a vertical problem, and you will realize that how we see a use of geometric progression in real life situations too, right? So here the number of bacteria in a culture doubles every hour. So what they are trying to tell you from this first sentence is, every time if you start an experiment at a certain time, then after every 2 hours the bacteria doubles, right? And if you observe, if there were 50 bacteria originally present in the culture, what is the meaning of this sentence? Here this is the sentence number 1, this is the sentence number 2. So originally there were 50 bacteria in that experiment. So friends, originally means at the time of starting that experiment, means at the start of the experiment there are 50 bacteria present. And here this is the meaning of the statement 2 or sentence 2. And what is the meaning of 1? After every 2 hours or every hour, so number of bacteria in a culture doubles every hour. So let's say these are the number of bacteria initially present. Let's mark this as A. Then after 1 hour, then this bacteria doubles. Doubles means it becomes 100. Then after one more hour, this 100 becomes 200. Are you understanding this thing? So after one more hour, this 200 becomes 400. This is the way these bacteria are growing after every 1 hour. So right, so means if you observe, this entire thing is in geometric progression. The growth in the bacteria represent a geometric progression. The reason is quite simple. Initially there were only 50 bacteria, but after every 1 hour, what is happening? After every 1 hour, the number of bacteria doubles itself, right? So this 50 becomes 100, 100 becomes 200, 200 becomes 400, and 400 becomes 800, and ultimately it represents the sequence is in geometric progression. So right, this is the first term of the geometric progression, A equal to 50, and if you take a ratio of 100 with 50, you will get 2. If you take a ratio of 200 with 100, you will get ratio 2. 400 by 200, ratio is 2. And since the ratio remains same, that indicates the sequence is in geometric progression. And here we got R equal to 2. So the ratio in this case is 2. First term is 50. And what they want, let's try to read that in sentence number 3. Now, how many bacteria will be there at the end of 5th hour? So now they want the number of bacteria after 5 hours, right? Means already we know the number of bacteria after 5 hours. This is the first hour, second, third, fourth, and one more layer that you have to increase, right? But let's cross check with this formula. They want the number of bacteria after 5 hours. So number of bacteria after 5 hours is the question. So right, means friends, this is the time where the experiment started. So it means we can consider this as a 0 term. Try to understand this thing. So this is 50 number of bacteria present initially, means whenever you start an experiment, that indicates a 0 time. This very number of bacteria present after 1 hour, then 2 hours, right? This is the situation after 1 hour. This is the situation after 2 hours, then 3 hours, 4 hours, and then 5 hours. So technically, if they are asking you what is the situation after 5 hours, means it is a which term of the geometric progression. So friends, be careful. This is the thing where it may possible that you will make mistake in examination. So right, so here whenever we start an experiment, we mention it as a time 0. Then this is the situation after 1 hour. This is the situation after 2 hours. This is the situation after 3 hours. This is the situation after 4. And we want a situation after 5 hours. So technically, if you count this thing, so here I am counting with this 50. So this is the term number 1. This is the term number 1. This is the term number 2, 3, 4, 5 and 6. So technically, if you want a situation after 5 hours, means you must find 6th term of that sequence, right? So the requirement is the 6th term. This 5 will confuse you in this particular problem, but don't get confused. Apply your own mind, apply your own common sense, and the requirement of the problem is 6th term of that sequence. And let's write a formula for Tn. Nth term of geometric progression is AR raised to n minus 1, and since we want 6th term, that indicates n value is 6, A value in this case is 50, R value in this case is 2, n value is 6 minus 1. So just do this calculation. So it's a 50 times 2 raised to 5. You know that 2 raised to 5 is 32. Do your maths and find out your final answer. This is 10 and 15. This is 1600. So this is the 6th term. So this is the situation after 5 hours. These many number of bacteria are present in that culture, right? So let's cross check with this. This first is a 50, then it becomes 100, 100 becomes 200, because every time after 1 hour, these bacteria are doubling itself. So 200 becomes 400, 400 becomes 800, and 800 becomes 1600, which is absolutely correct over here in this example. So right, so here manually also you can cross verify this question. So this is the final answer, right? Try to understand, friends, it's not about the 5 hours. What if they ask you after 20 hours? Why the mathematical formulas are important? So many of the students say this is a manual problem, you can easily guess the final answer. But let me tell you, it is very hard if they specify you what is the situation after 421 hours of the experiment. So means here the formula will help you in these questions where the digits are very high. Okay, let's switch over to the next very interesting vertical problem. I personally likes the vertical problems because that truly reflects the mathematical sense to the real life situations. Therefore, as a teacher, I really personally like vertical problems. Okay, what is this real life situation here? A ball is dropped from a height of 80 feet. So this is the sentence number 1. So here I am mentioning this as a sentence number 1. A ball is dropped from 80 feet. So right. Okay. So let's mark somewhere. This is the ground level. Let's say this is the surface level or ground level. And according to them, a ball is dropped from this 80 feet. Right. So this height is given as 80 feet. A ball is dropped from 80 feet. And obviously, whenever you drop a ball from such a height, it will bounce back, right? So it will bounce back once it reaches to the ground. Then retardation leads to the bounce back of that ball. So let's try to read or understand next second sentence of this problem. Now, the ball is such that it rebounds 3/4 of the height it has fallen. According to them, whenever a ball is dropped from such a height, so it only bounces back to the 3/4 of that height. So let's say this is nothing but the 3/4 of this height. Means I am talking about 3/4 of this 80 friends, right? So then this ball will reach up to this point. Then once again it comes back to the ground, and then once again it will reach to the next level. But make sure that this is also 3/4 of that layer 2 or the height 2. Then let's say this is the third height that it will reach. Then once again it will reach to the ground, and then it will achieve a 3/4 of this third height, right, which is nothing but 4th now. And then in next case it will achieve 3/4 of the 4th height, and it will reach to this, and after certain time gradually it will settle down on the ground. So right, so this is the way that ball will settle down on the ground. So this is the real life situation that you observed from your childhood. You played so many times this cricket and all. If you use any tennis ball or any sponge balls, you will observe that this is the thing that will happen. So please try to observe what exactly happening over here is a geometric progression. In what sense? Let me explain you. So initially the height was 80 feet. So please observe. And after this first bounce, the ball is reaching only 3/4 of that 80. Try to understand the meaning of this sentence. What is a 3/4 of the 80? If it starts with 80, I am asking you what is 3/4 of 80, right? So let's try to calculate 3/4 of 80. So this is 4 to Z, this is 20. Is it 60? So this is 80. The next level is 60, right? So initially the height is 80. So here I am writing for you. Initially the height of the ball where it is released is 80. Then after 3/4 of this traveled it will travel 3/4 of that 80 and it will reach up to 60 feet only, right? Okay, what about the next? In third case, it will achieve a 3/4 of, understand this, 3/4 of that 60. So understand this thing. So what is the 3/4 of the 60? The next level is 3/4 of that 60. So what is this calculation? So here I am calculating it. So it's a 15 into 3. Is it 45? This is the next layer that it will achieve. So means every time it is. So here I am continuing. Try to observe this thing. So the first height of the ball is 80, right? The first of the ball height of the ball is 80, then second one is 60, then the next layer is 3/4 of the 60. So friends, try to observe here, 3/4 of the 60 becomes 45, right? Okay, so here I am mentioning the third layer, or the ball will reach up to 45 feet. The first thing is, when it is released, it was 80 feet, then in second bounce, first bounce it will reach to 60 feet, in second bounce it will reach to 45 feet, then the next layer is obviously 3/4 of that 45. So right, so in next case it will bounce back to 3/4 of the 45. So right, so please calculate this thing and just check what exactly is your answer. So right, so try to understand this, friend, what I am trying to tell you. So if you continue this entire series, it is in geometric progression. So try to observe, just take a ratio of this 60 with 80. So if you take a ratio of 60 with 80, then it becomes 3/4. If you take a ratio of 45 with 60, then it is also 3/4. So are you observing? The ratio of two successive terms remains same. So as far as this sequence is concerned, this is a geometric progression whose first term is 80, common ratio is 3/4, and please try to find how high does the ball rebounds on nth bounce. Means what you have to find out here in this problem is Tn for this geometric progression, which is very simple. Simply apply formula for ar raised to n minus 1, substitute r, you will get your final answer. So I'm requesting every one of you, do your calculation and send me your final answer in comment box. So here I am switching. I don't want this video to be very lengthy, so I put a lot of time on explaining this problem, which was very important one. I'm keeping the calculation for you. Okay, so let's switch to this next problem very quickly. The numbers 3x and x plus 6 are in JP. So according to them, these three numbers are in JP. Now your task is to find x, then 20th term and nth term of that. Very simple problem. According to them, these 3x and x plus 6 are in geometric progression. If the three numbers are in geometric progression, then the ratio of successive term, that is x divided by 3, is r. The ratio of these two successive term is also r, since it is in GP. So here I am taking the ratio of x with 3 and the ratio of x plus 6 with this x. So try to understand, here I am taking the ratio of two successive terms. The first one is x with 3, second one is x plus 6 with x, and that ratio will remain same. So this ratio is also r, and this ratio is also r, right? So let's simplify this thing further. So I'm shifting the terms on LHS and RHS. So this x into x becomes x square. Shifting 3 on this side becomes 3x plus 18. It will be a quadratic equation. Shifting all the terms on LHS. So x square minus 3x minus 18 equal to 0. So let's simplify it further. 18 is the term whose factors are possible, and they want these factors to be a difference as 3. So just split this 18 so that its difference is minus 3. So how will you split? Is it a minus 6 plus 3? So these are the factors: x minus 6, x plus 3 equal to 0. So possible values of x are either 6 or minus 3. So right. So these are the possible values of x, and here we got answer for the first thing. What is the value of x for this sequence? So what do you think, friends? If I take x equal to 6, so these are the three terms of the geometric progression. So x, 3x and x plus 6. So let me write the geometric progression again. So it is 3, then x and x plus 6. What if it is x is equal to 6? Then it becomes 3, 6 and 12. And if you observe, this is in GP. What if it is x equal to minus 3? The first term is 3, second term is minus 3. And if you substitute minus 3 and minus 3 plus 6 is plus 3. And please observe, this is also in geometric progression. So right, then they want the 20th term. I'm going to do the calculation for this term only. So how to find 20th term? So for that, just use a formula for Tn, which is ar raised to n minus 1. So right, to find any term of geometric progression, we use formula for Tn. And formula for Tn is ar raised to n minus 1. And since they want 20th term, means their requirement is T20. That indicates the value of n is 20. A value for this sequence is 3. Then r, or the ratio, 6 divided by 3. So right, a in this case is 3, ratio is 6 by 3 is 2, or 12 by 6 is 2. So r in this case is 2, n value is 20 minus 1. A very simple problem. This is 3 into 2 raised to 19. So this is the answer for question number 2. That is, they want the 20th term of the sequence. So if you continue this particular sequence up to the 20th term will be 3 into 2 raised to 90. This is what they want to find. Okay, so don't do the calculation. 2 raised to 19 is a very huge value. So keep this thing as it is. Now let's try to find the nth term of such a sequence. And formula for Tn is ar raised to n minus 1. Please use this value of a and value of r and substitute here in this formula. So Tn is a value is 3, r value is 2 raised to n minus 1. And this is nothing but the nth term of that geometric progression. So here we got the nth term of geometric progression. Here we got the 20th term of that geometric progression. And here also we got this geometric progression 2. So right, okay, so here I am keeping this level of calculation with you. So do the calculation on your own and find out your answer. If you want, you can send me your answer in comment box. Then I am switching quickly to the next problem, which is a vertical one. And obviously I like vertical problems because it relates to real life situations. So mosquitoes are growing at a rate of 10% per year. So this is the rate at which these mosquitoes are growing. This is the sentence number 1. Then if there were 200 mosquitoes in the beginning means this is the first term of geometric progression. So right, try to understand. They started with experiment, and they say there are 200 mosquitoes initially, and every time these mosquitoes are increasing by 10%. So right, so try to understand the meaning of this. Mosquitoes are growing at the rate of 10% per year, right? So what is the meaning of that? So if this is the thing where they started with the 200 mosquitoes, then after 1 year the mosquitoes are 10% of that 200. So right, the next number of mosquitoes are 10% of 200. Next one is 10% of whatever is its answer. The next is 10% of whatever is the answer for this thing. So right, so let me explain you in detail. So they started with 200 number of mosquitoes. What is a 10% of 200? Because that is the growth. The growth at which these mosquitoes are increasing is 10%. Try to understand the meaning of this. So every year mosquitoes are increasing by 10%. So here I am calculating 10% of 200. So friends, percentage is always about out of 100. And if you do this simple maths, you will get mosquitoes will increase by 20. So if the initial number is 200, then the 10% increment means just add 20 into it. If you add 20 into this, it becomes 220. So in the next year, you will observe that mosquitoes will increase 10% of 220. Try to understand this thing, right? And things goes on, and you will observe that the sequence is in geometric progression, in which the first term, so we are interested in only A and R of the geometric progression. Don't waste your time in doing the lot of calculations. So here we got A, which is 200, and if you want R, just do this simple calculation, 220 divided by 200. The 0 get cancels out, then it is 11 by 10, right? 11 by 10, or if you want, you can write it as 0.1. So let's mark this as 0.1. So friends, I request every one of you, don't waste your time in doing lot of calculation, because only these two terms are important in geometric progression. First is A and the second one is R, and by observing just two terms, this is the first term and this is the second term, just by observing these two terms you can easily find out the value of A and value of R. Once we know A and R, it is very easy to solve any kind of problem from the geometric progression. Then let's try to read the third statement of this vertical problem. Now they want write the number of mosquitoes after 3 years and then after 10 years. Okay, so they want the number of mosquitoes after 3 years. What is the meaning of that? So here they started, this is what where the students, most of the students make mistakes. So let me explain you friends. They started with 200 number of mosquitoes. Then after 1 year, it reaches to 220. Then after 2 years, it will reach to something. Then after 3 years, it will reach to the something. So right. So this is the process which is happening. So this is the first term. This is the second term. This one will be the third term. Right. Now try to understand. This is the experiment where they started. So observe this. So this is not a first year, even though it looks like a first term, but this is not the first year. This is the experiment where it is started. So you must start with 0. After 1 year, this is the situation or number of mosquitoes. Then after 2 years, this many number of mosquitoes are present. And then, so this is the digit where number of mosquitoes are present. Let's mark this as T2. And after third year, this many number of mosquitoes are present. So try to understand. So here I am mentioning this is the initial number of mosquitoes. Sorry for that. So let me check. This is the number of mosquitoes initially present. So don't mark this as T1. This is like a T0 where we started the experiment, right? Then the number of mosquitoes after 1 year becomes 220. That is the first T1. Then after 2 years, it becomes something. We don't want to do that calculation, but that will be T2. Then after 3 years, it will be something. And obviously, it will be T3, right? Okay, then they want a situation after 3 years. So technically speaking, friends, as far as terminology is concerned, if I assume as a geometric progression, this is T1, this one is T2, this is T3, and this is T4, right? So this is the false thing. If you observe it carefully, this is the thing they want, and actually after 3 years, if they want the number after 3 years, means technically speaking, they are in requirement of the fourth term of that geometric progression. There is a difference between the number of years and the number of terms in this kind of problems. I hope every one of you got this very interesting and tricky thing. And let's try to find fourth term of geometric progression. Formula for Tn is AR raised to n minus 1, and technically speaking, they want to find fourth term. And in this case, A value is 200, R value is 0.1. Since they want the fourth term, N value is 4, so it's a 4 minus 1. Final answer is 200 into 0.1 raised to 3, right? So do this calculation. I'm keeping the calculation up to you. My job was to clear your entire concept of this very interesting vertical problem. Then I am quickly switching to the next problem, friends. Find 4 numbers in GP. This is something different that we discussed in summary of geometric progression. Find 4 numbers in GP such that sum of the middle 2 numbers is 10 by 3 and their product is 1. This sentence is very, very important. Their product is 1. Now this question belongs to 4 numbers in GP. So right, let's try to select 4 numbers in GP where product is given. If you observe in summary, we already discussed this particular thing. So here in summary of geometric progression, friends, we already discussed this concept. I am talking about this thing. 3 numbers in GP if product is given. Read this one note, note number 1 I am talking about. If product of numbers is given, this is the way that you have to select 3 numbers in GP, 4 numbers in GP and 5 numbers in GP. And there is a different rule if the product of numbers is not given. And here I am talking about note number 1, product of numbers is given, and please select the 4 numbers in this way: A divided by R cube, A divided by R, AR and AR cube. So here, coming back to this original problem, so we want 4 numbers in geometric progression and product is given, right? So please select the numbers in this way, like A into R, A divided by R, then AR cube, A divided by R cube. So if I mention it, this is the first number of geometric progression, this is the second number, this is the third number, this one is fourth number. First, second, third and fourth term or fourth number of geometric progression. Okay, now let's try to, after selection of these 4 numbers, let's try to convert that data into a formula. Find So find 4 numbers in GP such that the sum of middle 2 numbers. Sum of middle 2 means they are talking about 2 and 3. So sum of middle 2 numbers. So if they are talking about sum of middle 2 means they are talking about 2 plus 3. And sum of the middle 2 numbers is 10 by 3. So this is equal to 10 by 3. Means with this sentence what they want to give you is A divided by R plus AR is 10 by 3. Let's mark this as equation number 1. What else is given? Then their product is 1. Means product means they are talking about product of all the 4 terms. So if you take a product of all the 4 terms, product is 1. So product of all the terms is A by R cube into A by R, then AR and AR cube is given equal to 1. So please observe it carefully. They provided you the product of all the terms and it is equal to 1, and it creates an advantage in solving this kind of problem because it cancels this R cube with R cube, and we can easily cancel this R with R so that one of the unknowns get cancels out over here. So please observe, I am cancelling this R cube with R cube, this R with R. So what is left is A into A into A into A. So 4 times A. If you observe, A raised to 4 is 1. So here I am expressing A as a 1. It may possible that plus minus 1, but for the sake of simplicity, I am using this A as a 1. Let's substitute that in equation 1. So this becomes 1 upon R plus R equal to 10 by 3. Try to observe, I substituted this value of A over here and here in equation number 1. So let's simplify it. That will leads to the value of R. So here I am multiplying throughout by R. It becomes 1 plus R square equal to 10 by 3R. Still the fraction is present. Let's multiply throughout by 3. 3 plus 3R square equal to 10R. So finally the quadratic equation is 3R square minus 10R plus 3 equal to 0. And if you observe, Factorize this 9 so that addition is minus 10. Obviously, the factors are minus 9 minus 1, 3r square minus 9r minus r, then plus 3 equal to 0. So what are the factors possible? If I take this 3r outside, r minus 3, minus 1 outside, r minus 3. So overall what is common? So this r minus 3 is common. So the factors for this quadratic equation are r minus 3 and 3r minus 1. This will leads to two values of r. Either r is equal to 3 or r is equal to 1 by 3. Correct? So here we got a very important term of geometric progression. The first we got this value of a, and after doing a little bit labor work or after doing a little bit heavy calculations, we got these two values of r. Then on the basis of this, let's put the case number 1 for the GP for which a value is 1 and r value is 3. Let's try to put that in 4 numbers. We selected already the 4 number as a by r cube, a by r, a into r, ar cube. So I request every one of you just put this value of a equal to 1 and r equal to 3 and just complete the numbers. So is it 1 by 3 cube is 27. Then a by r is 1 by 3. A into r, that is 1 into 3 is 3. And the last one, 1 into 3 cube is 27. So these are the 4 numbers required in the given problem. So if you observe, this is the first number, this is the second, this is the third, and this is the fourth number. The question is all about finding 4 numbers in GP. And if you observe here, we got these 4 numbers for the case number 1. But let's cross check and you will observe a very interesting hint, friends. What do you think? What will happen in this case number 2? With a is equal to 1, I am keeping a equal to 1 as it. I am talking about this a will remain same. There are 2 possible values of r. So if you observe here, there are 2 possible values of r. R is equal to 3 and r equal to 1 by 3. That's why I am therefore I am discussing these 2 cases. So case number 2 in which I am selecting r equal to 1 by 3. So a equal to 1, r equal to 1 by 3, and please apply these 2 values to these 4 numbers. First number a by r cube, second a by r, third is ar, and fourth is ar cube. If you substitute, you will observe a very interesting fact. So observe here I am substituting everything. A is 1 but r is 1 by 3, its cube. This is the first number. Second number, a is 1, r is 1 by 3. Next one in the list is 1 into 1 by 3. And the last one is 1 into 1 by 3, its cube. What is your observation? 3 cube will be a part of numerator. So it's a 27, then 3, then 1 by 3, and the last one will be 1 by 27. So these are the 4 numbers in case number 2. And what is your observation? This is number 1, this is number 2, this is number 3, this is number 4. So what I am trying to ask you, what is your observation from this case number 1 and case number 2? So if you observe, both these things are in geometric progression, but only thing is the pattern of the number is reversed. In first case, if you observe, it is 1 by 27, 1 by 3, 3 and 27. It is exactly reversed order in case number 2. 27, 3, 1 by 3 and 1 by 27. So, right. So, here we got 4 numbers in GP. This question belongs to the 4 numbers in GP with these 2 given data points. Right. Okay. Let's try to solve the next question. I'm going to give you a hint for this for sure. Okay, so let's start with this question. Find 3 numbers in GP. So this question belongs to 3 numbers of GP such that their sum is 35, and this is important sentence. Their product is 1000. So let me tell you, friends, this is very important sentence to select numbers in GP. So here I am mentioning 3 numbers in GP provided product is given, and try to recall the data from the summary. If the product is given and we want the three numbers, then please select the three numbers in the way A, AR and A divided by R. So if you remember, this is the way that we select three numbers in geometric progression if product is given. So let me explain you in detail the first sentence. The first sentence is all about find the three numbers in GP such that their sum is 35. So what they want to tell you is 1 plus 2 plus 3. Sum of all these three numbers is 35. Means A divided by R plus A plus AR is given equal to 35. Here I am marking this as a 1. And in second sentence, if you observe, and their product is 1000. So let's take a product. Product means multiplication. So A into R, then A, then AR. This product is given equal to 1000. Right? What is the benefit of this equation 2? The real benefit lies in the product. If you observe, since they gave you this particular sentence, this R get cancels from the numerator and denominator. What is left is A cube, right? And 1000 is also 10 cube. Then this with this comparison that leads to A equal to 10. And here we got a first important factor of the geometric progression, that is A equal to 10. So important term of the geometric progression is A equal to 10. And now do simple job, substitute this value of A in equation 1. So it becomes, if I take that A common from this equation 1, it becomes 1 upon R plus 1 plus R equal to 35. I'm talking about equation 1. Now, since we know this value of A, substitute over here. This is 1 upon R plus 1 plus R equal to 35. Shift this 10 on the right hand side. So this expression leads to 1 upon R plus 1 plus R equal to 35 by 10. Right? Overall, it's a 1 upon R plus 1 plus R becomes 7 by 2. Is it 7 by 2? Okay. Then multiply throughout by R. I don't want this fraction, so I'm multiplying by R. It's a 1 plus R square equal to 7 by 2 times R. Even I don't want this fractional 2, so let's multiply throughout by 2. So it's a 2 plus 2R plus 2R square equal to 7R. And it leads to a quadratic equation. 2R square, then shifting this 7R on this side, so 2R minus 7R is minus 5R plus 2 equal to 0. Solve this quadratic equation and you will get the value of R. So right, I don't know the value of R. I'm keeping the calculations up to you. This will simplify and will leads to the value of two values of R. So right, so here this is not the exact answer, but solve this and find out the value of R. Right. Once you got the value of R, you will get one or two values of R. So it's a quadratic equation, so obviously two values. Once we know A and R, we can do anything in geometric progression. We know the value of A, which is 10 in this case. And now after doing this calculation, you will get R. Then quickly find out three numbers of GP as A by R, A and AR. So substitute that values over here in this. So this is the number 1, this is number 2, and this is number 3. So I request every one of you, I already explained the entire details of this problem, entire concept of this problem. Even I reached up to the calculation level of finding A equal to 10 and even reached up to the calculation level of finding R. Right, now it's a simple job left with you. Find out R and substitute here in these three numbers, and at the end you will get the required three numbers of the geometric progression. So with that hint, I'm switching to the next problem. Example number 15. Find a GP. This is a very important one. This is the real question that I want to explain you. This is something different from the previous two. Find a GP for which sum of the first two term is minus 4 and fifth term is 4 times the third term. So this question also belongs to the numbers of geometric progression. So right. And what do you think? How many numbers are involved here? Since they are talking about the fifth term, means totally 5 numbers are involved in this GP. So this question indicates of 5 numbers of GP. But I already discussed there are two cases either a product is given, product of all the numbers is given, or the product of the numbers is not given. And every time try to catch this particular sentence in the given statement and in the given problem. And if you observe, product is not given in this problem. So this is the question that I want to discuss with you. In previous two cases, if you observe, this previous question was also about the numbers in GP, but this one was the real interesting part. They already provided you the numbers, product of the numbers, right? If you observe the previous question, that is question number 13, the product of the numbers was also given, right? And then we selected the numbers in this fashion. But as per as this problem is concerned, friends, product is not given. And if the product is not given, then there is a different way in which we select the numbers. If you remember the summary, select the numbers in ordinary way, we write a geometric progression. So first term is A, second term is AR, third term is AR square, then AR cube, and the last one is AR4. This is the way that you have to select the numbers in GP if product is not given. And since this question they reached up to the fifth term of the geometric progression, means I am selecting here 5 numbers in GP. So here I am selecting 5 numbers in GP as A into R, AR square, AR cube, AR raised to 4. Right? So these are the 5 numbers that I am selecting on the basis of this very important sentence, product is not given. That's why I am changing the strategy. So these are the 5 numbers in GP. Okay, now let's do the calculation, or let's do the maths. Okay, the first thing is find the GP for which sum of the first 2 term is -4. So understand this, sum means addition. Sum of the first 2 terms is -4, means they are talking about these two. So their sum, A plus AR, is given equal to -4. So this is the first thing they provided you. The sum of first 2 terms, that is 1 plus 2, is given equal to -4. And according to them, the fifth term is 4 times the third term. Fifth term is 4 times the third term. This is the thing which is given. So previously they provided you 1 plus 2 is equal to -4. That leads to the equation number 1. And try to read this thing. Fifth term is 4 times the third term. Observe this thing. Fifth term is 4 times the third term. Is it correct? Fifth term is 4 times the third term. So what is the fifth term here? Fifth term is A raised to 4. 4 times the third term is AR square. What is the benefit of that? If you will observe, this will eliminate one of the unknown, which is nothing but A in this case. So please cancel out this A from LHS and RHS. Also you can cancel out R square. So what is left is R square equal to 4. This leads to 2 values of R plus -2. Obviously that creates the 2 cases. First one with R equal to +2 and second one with R equal to -2. But I am going to discuss only R equal to 2, and I am keeping this thing for your self calculation. So right, okay, so let's solve with this R equal to 2. Now we got R equal to 2. Substitute that R equal to 2 in equation 1 and quickly find out the value of A. So A plus AR is given equal to -4. What is common here is A, so 1 plus R equal to -4. Here I am substituting the value of R as a 2. So what is the value of A that you will get? -4/3. So right, so here we got the value of A, value of R. Then for a GP, these 2 terms are very important one. A is -4/3 and R I am considering as a +2, which is the case number 1. And let's try to find these numbers. What is asked? Find the GP for which. So they want the numbers of the GP, and as we already consider these as A, then AR, AR square, AR cube, AR raised to 4. This is the GP. I request every one of you substitute all these digits here in this pattern. So a is minus 4 by 3, which is the first number. For the second number, a into r, it's a minus 4 by 3 into plus 2. This is the second number. For the third number, a is minus 4 by 3 and r square means 2 square. For the next number, it's a minus 4 by 3 into 2 cube, and do the maths and find out the first term, second term, third term and fourth term of the required geometric progression. So I hope you got this particular question, example number 15, which is totally different from 13 and 14th case where the product was given, and in this example number 15 nothing was given. So friends, I hope with this 15 examples on geometric progression you will get an entire idea about the geometric progression. I think we touched each and every details of the summary of the geometric progression, and we discussed these problems and very interesting vertical problems too, and we discussed each and every terms of the geometric progression. I expect this problem solving session definitely will clear your idea of the geometric progression and will help you in solving few more questions on geometric progression. This is all what purpose of this important videos. I want to clear your concept and I want to help the students in solving problems on this geometric progression, and I hope I reached up to your expectation of this thing. So enjoy learning mathematics, and goodbye and take care.